All right, thank you all for coming. I'm Craig. I work in the Google Enterprise team on the cloud platform. And what I want to spend a bit of time telling you about today is some of the things that we've announced recently and some of the new advances that we feel will be leading the industry over the next months in the area of cloud. So another quote from Snapchat. They just had a great release yesterday of a video product which is powered by the cloud platform, so you can just hold your finger down and video chat to someone for the period that you're doing that. So still very much in their original idea of ephemeral conversation based around pictures, but now much more throughput, much more capacity required, easy to do on the cloud platform. They've got about 25 engineers now. They have a couple of people who do a little bit of ops stuff every now and then, but in general, by picking Google App Engine, they can have their developers focus on new features. You don't have to worry about provisioning servers, load balancers, all the stuff Riff mentioned before. It's very easy. You write code, you give it to us to run. We have a team of site reliability engineers who look after everything for the platform, so all you have to think about is writing your own code. Even though we've got this, we believe at Google that cloud is still too hard. And there's two main areas that we're attacking. The first one is the complexity of pricing. So if you've used cloud before, you're familiar with the idea, you pay a little bit for your servers, you pay a little bit for your disks, you pay a little bit for your networking. Altogether, you'll get something that is a lot cheaper than doing things the traditional way, but you quite often need to have a PhD in statistics to figure out pricing models and what the best thing to do is. Second area is that current clouds force you to make trade-offs in decision. So if you've chosen to adopt a platform, you might find that you outgrow that. And a number of famous startups, Twitter for example, built on Ruby on Rails and got to a point where you were seeing the whale all the time because they just couldn't handle the load. They had to stop, they had to re-engineer, and they've got a really great service today, but they had to bring on a completely different team in order to be able to do that. We think you should be able to start here and get to here without having to change anything along the way. And there's some announcements that we've made to talk about that. So first of all, the price of cloud has fallen over the last few years, but the price of hardware has fallen at a far greater rate. So when you think about Moore's law, which says the compute power should double every 18 months, it goes to say that the price of running a standard unit of compute should halve about every 18 months. So we've done two things in order to equalize the market around this idea of Moore's law. First is the on-demand price reductions, and second is an innovative new model for pricing around sustained use. So with on-demand price reductions, we've dropped the price 32%. All the other vendors drop their price to match pretty much the next day, but only on the things that they compete with. So we're really setting the market trend for where prices should be. So that goes across every compute thing we run, all regions, all sizes, all classes. Cloud storage. Other vendors drop their price not quite as ambitiously as this, but now everything you store on the cloud, it was previously around 7 or 8 cents a gigabyte, and you'd sort of have tearing down to about 5. We've dropped that to a flat 2.6 cents per gigabyte. I don't think you can buy hard drives for that price on the common market. If you want what we call durable reduced availability, we back it up in a small number of data centers. It's now only 2 cents per gigabyte rather than 2.6. So great for archive data. We have a big data product called BigQuery, and we probably won't have time to talk about it today, but as has been mentioned, it lets you query across all of the information that you might have, petabyte scale, every event that's ever been generated, every edit on Wikipedia, you can do a query over that in 5 or 10 seconds, something that traditional databases can't do. It was previously $35 per terabyte processed. We want to democratize this capability that we use internally at Google. We want to make it available to everybody, so the price has been dropped to $5 per terabyte. And at the end, we'll have a chat about how we can give you some credit to get involved with this. We have great opportunities for if you outgrow the need for this, if you need to do streaming stuff, probably not at initial scale, but you can purchase reserved capacity for BigQuery. And effectively, it'll cost you 4 times as much to do what you do on BigQuery with industry pricing for other vendors that don't even let you perform it as quickly. So to recap, end of March, we reset the pricing in the market. We found that a number of other vendors made similar cuts, but they're really just sort of paying lip service to the idea. Google have been running this kind of scale internally for 15 years, and we want to make this available to everyone. We want to make it available to all developers who want to come along and use our platform. That was the original promise of the cloud, is you could say, well, I want some of this today, and I want some of that tomorrow, and you can balance things. But the model that got adopted was, well, I've got to buy a reservation and that'll grant me the right to run this at this price. And it really doesn't go along with what we thought the original model was. This is what I talked about before about pricing models. You say, well, if we just use it, we'll pay this much, but we can buy reservations which allow different things. And there's the idea of having to model your pricing, and then, well, that doesn't really go with, well, I don't know what I need to use today. And if I'm lucky, then I might have this problem. Or if I want to fail fast and try a lot of things, then what do I do? Is it worth taking the upfront discount in order to be able to potentially succeed over time? So we think what you should get is the best price regardless. No upfront payments, no lock-in, no complexity. So what we've launched is sustained use discounts on our pricing. So that was our old on-demand rate. You'd pay sort of 10.5 cents an hour. So let's say 32% drop to start with. That's our new on-demand rate. And the more you use, the less you pay. And so overall, it averages out at the same rate that other people offer reservations. But if you use 100% of a month, so if you run a server full-time over the course of a month, the rate is effectively 20% lower than it was beforehand. So that works out to a 53% price drop if you're using sustained compute over the course of that month. So that's just a little recap of what we've done to the pricing in the industry. That will help you realize the initial promise of cloud computing, which is predictable low pricing and aligned with Moore's law. But cloud's still too hard. You have to make trade-offs to work around the weaknesses and limitations that cloud vendors offer. You have to choose between a quick time to market, like I mentioned with Twitter before, or scalability. You have to choose between flexibility or automatic management, so the scales that Alex was talking about before between a managed service and a lower level compute service. And when you're doing big data, you have to choose between, do you want to be able to query in a lot of information, or do you want to be able to access it in real time? And what we're doing here at Google is changing the or to the and in all of these cases. I'll just quickly talk you through what we're doing here. Developer productivity, we don't want you to have to choose between time to market and scale. We want you to be able to use the tools that you love. We want you to be able to do deployments quickly. We want you just to be able to push code to us, and then we'll worry about everything else. We want to be able to offer an ability to look across the logs for all the applications you're running, find and fix errors in production quickly, let you get out there, let you put test environments up, and more importantly, let you see when things are going wrong in the real production environment and change them. Now I'll try my little demo. The easiest way to do this might actually be just to look at the screen. If I can... Nope. So I've come up with a completely original idea for a mobile application, which is in no way derivative of anything whatsoever. So I've got my little app running in production, and the great news is I'm not very good at it. You're welcome to give it a go and see. What? One? Right, so see here, I probably don't have a very high score. So I go and look at the high score table and see that well, my score of 1 is being registered. Obviously, turns out that my broken demo possibly isn't as broken as I'd hoped it would be. But what we did is actually introduce a bug in this that we want to demonstrate. So all of the logs generated by this application are available here in our log console. And if we have a look at this one, for example, you can see here that there's an error message that says there's an error uploading a high score. And so in the action of refactoring our code, and we've made a change, we've pushed it to production, and we've actually got an error. And what you can do now is you can click through from the production log console to the actual source repository. So I can come in here and I can see the code that's in the Git repository that we provide, and you can also link this to GitHub if you're using that for collaboration. And we can see the error that's generated here is to say if the user is If the user's not an admin, then throw an exception. And we obviously want everyone to be able to participate. So what we can do is just go into hit the edit button there, and we can actually make changes to this. So we don't need that line of code. So what I'll do is comment that out. Now that might be something that you're familiar with doing if you're a developer, is logging onto a machine, and then what you obviously do is you're setting up a situation, well, it's out of sync now, I've made a change and it's not in my repository. What this is actually doing is this is committing code to our repository. And this gives me a chance to introduce our new build test pipeline to you. So under cloud development in our cloud console, we have a connected Git repository, and this app's written in Java and it uses the Maven build system. So that fix that I've just committed, that's actually being sent off to a virtual machine running at Google, which is connected to your account. It's built, so it's pulling that code down, it's compiling it for you, it runs all your unit tests, you see that's just gone past, and then it's deploying it. So this is exactly the same pipeline that your developer would use if they're developing locally on their machine. They'd commit a change, they'd push it, and then it would deploy. And that's available for you to do collaboratively through the web. You can go through for any of these changes, you can go through and look at the differences. So that one, they changed the logo, so that's not too exciting, but if I go back to one with some source. So previously we had a unit test here. The unit test, if we do a longer example, will show you that making that change actually breaks the unit test, so you can go through and change them as well. And so now, having made that change and changed the source for that function, it will let you save your high scores. Seeing as I can't get much past 1, it's probably not worth me trying. But that's an example of some of the DevOps tooling that we've made available in the Google Cloud Platform. So, flexibility and management. Alex touched on this before. You have the choice to run anything you want if you run it on a traditional server, or you have the choice to write code for App Engine, which lets us scale it very quickly, make it available through the log viewers and all the things you just saw there. We want to make that available to everyone coming from both ends of the problem of serving. So we've made available managed virtual machines. And the idea here is that it lets you use the flexibility of Compute Engine, but still have the productivity of being able just to write code and push it to us. So what you can do, and so I don't have time to give you a demo now, but you can take a module of your code and say, I want to run this on a VM rather than running it in App Engine. And what that does is it lets you install other software on there. So with App Engine, for example, sorry if I'm going too deep for people, but you can't use modules. So if you have some PHP code and you want to install a extension to PHP that's written in C, we don't let you run arbitrary native code. But if you want to use a VM to do this, you can say, just install this module. So a great example of this is we have a demo which you can look online at the URL at the end, which is a Sudoku solver. And it uses a computer graphics library. So you can point a camera at a Sudoku, and then it uses a C++ library to do image recognition of that Sudoku, and then read the numbers, feed that back into a Python algorithm, and then give you the solved Sudoku. So that lets you have high availability. We look after those machines. We have them come and go as they need to. We instantiate them. They're managed through the console. The logs go into the same place that you saw before. We will make sure that they're security patched, so we will take your code, deploy it onto those machines, and then manage them as necessary. So this is the slides that Alex started presenting before. We want to be able to go as a spectrum, and you can't quite see the grey boxes with the projector, unfortunately, but the lowest level you have Compute Engine, which is just you have to look after your own servers. A level up there, we offer a tool called replica pools, where you can say, I have a bunch of servers that all do the same thing, and I'm just going to say, as long as they respond this way, then they're healthy. And so you can just take your server image and expose an endpoint to say, I'm healthy, and then if they stop being healthy, Google will automatically terminate them and turn on another one. Managed VMs, I just mentioned, sits on top of that. and then these traditional App Engine managed runtimes. So we're really trying to make this a spectrum between flexibility and agility where you can choose where you want to be. And that's not a choice you have to make initially. You can say, up front today, App Engine's great for me, but then if you want to do things that it doesn't allow you to do, we'd call it breaking glass, and you can move further down the stack and introduce lower level components over time as you need. And it's as easy as just pushing again using either Git or our gcloud SDK to say, this is my app, I want to update it, send it to the cloud. So under the hood, I'll just give you a quick overview. A load balancer will turn on the machines, run your application server, any third-party libraries that you specify, and the code that's in your repository. We look after everything else over here. So monitoring and health checking, if you want to use services like task queues, memcache, and sitting on top of our cloud data store. You don't have to worry about anything other than your own code and specifying if you want to use any third-party libraries. Those parts in yellow are the only things that you need to provide. Google will manage all the rest for you. Big data, real time. With BigQuery, we can ingest 100,000 rows per second. So this is obviously of interest to people who are doing hardware startups. So if you're doing sensor information, we have a partner in Seattle who have got electricity meters in 40,000 homes that once a minute send a ping of usage back to the electric company, and it lets them graph outages on a map. So they can see the power's gone offline in these areas, or they can predict problems. So there's all sorts of interesting problems. You don't have to wait until tomorrow I can look at yesterday's information. You can see that in real time. You can go back and say, what was the state of my data 6 hours ago? You can say, how have things changed? And we have some great visualization partners which help you look at this. Just one more slide there on things that we think are really driving the growth in big data. Because, say, sensors, low cost of ingestion, new programming models that let you do parallel data processing, and being able to use open source software and being able to pay as you use with the cloud. Today, when you're looking at a new business, you should say, every single piece of information I ever collect, every event a user generates on my app, everything that happens on a mobile website, I'm going to store that. Big data doesn't necessarily mean big in a small company. It might just mean everything. Store every single piece of information, every bit of intelligence you can. Then later on, you might think, all right, well, I can think of insights. I can think of a way to track users went through this particular flow. What percentage of people bought a product after having looked at this page? What percentage of people dropped off after getting to a point? How many people played one level of Fluttery Bird and then gave up because it was too hard? All that kind of insight you can get. And you don't need to think about it today. You can store that and then query it in real time whenever you need. So that's me. Thank you very much. I just want to announce my colleague Yoav's down the back. He's going to give us a wave. If you're interested in $20,000 worth of credit for use of the Google Cloud Platform, we have a pack for startups. Qualification is based on basically for new companies who have not been around too long and have not taken too much funding. So if you're interested in finding out if you're eligible, he'll be around in the break to have a chat. Are we all right for questions, or how are we for?